Okay, so we have here carbon. So I'm drawing a acetate right now, CH3COO minus. So it's a C with 3 H's. And if you recall, how many bonds does carbon like to form? 4. CH3, and then we have a C. And this is a very typical organic, we call them a functional group. It means it's a group that shows up all the time and has predictable properties. The negative charge is on this oxygen. Okay, do you see how that oxygen actually has an extra electron? Maybe you can't. I don't know. Anyway, the negative charge is on that oxygen. And so when it becomes an acid, if we have an H+, where would the H+ like to attach to? What do pluses and minuses do?
Attract.
They attract. And so that H+ is going to be attracted to that negative O, so we will end up with C H3, C, double bond O, O, H. So what you can see is that we have this hydrogen here. This is the one we call the acidic hydrogen. These ones here are not acidic hydrogens. And the reason they're not acidic is they won't come off when you dissolve it in solution. The whole thing about an acid is that when you dump it into solution, H+ ions come floating off. Okay? And this would be what it would look like in solution. The two ions would be separated. The H+ would be floating around separate from the acetate. At this point, it's not really important that you know that. But what you should know is that when you form the acid based on acetate, although it would be okay to write HCH3COO, that's okay. But it is better if you write CH3COO and then you put the H on the end with the O. Okay, and that's because that's where it sits. It sits on that oxygen. Okay, so either of them would be okay when you actually form the acid, but it's better to put it on the COO. And if you're confused by that, don't worry, you'll get practice. Okay? So you will be using those parts of your chart in order to do the acid naming. And acid naming is, I'll just give you guys a second to copy that down. What's done with my green book? Oh, man. Oh, no. Maybe I took it home. All right. Not 4.4. 4.5. Ah, yes. Okay. So recognizing acids. This is just sort of a preliminary thing. You need to be able to recognize that you have an acid. So it's either going to begin with an H or it needs to end in COOH. And if you have an acid, I want you to give it the acid name. Give acids their acid name. Not their regular covalent name. What page are we on? We are on page 78. Page 78. Sorry about that. So for example, up to this point, we would have been naming HCl as hydrogen monochloride. However, now, because we are learning acid names, you instead are going to call it hydrochloric acid. Okay? To be truthful, both names are correct. When we have HCl aqueous, that's going to be the acid. If you have HCl gas, it's going to be hydrogen monochloride, but I don't expect you to know that at this point. So anytime in this unit, if you see HCl, name it by its acid name, okay? If you see H2SO4, name it by its acid name. If you see H2SO3, name it by its acid name. Do not call it hydrogen sulfate or hydrogen sulfite, okay? Instead of hydrogen sulfate, you're going to call it sulfuric acid. H2SO3, you'll call it sulfurous acid. H3PO4, phosphoric acid. H3PO3, phosphorus acid. Carbonic acid. There's a whole bunch of other ones here. We have our hydrofluoric acid. Now, I don't know if you guys remember from a couple days ago, we talked about a way of remembering this. This F ion, what is the name of the F ion? It's called fluoride. Okay, so that is fluoride. And my ride has hydrol X. Okay, so you take fluoride, you take that root fluor, you take off the "ide", you put hydro at the front, and you put ic at the end. So fluoride becomes hydrofluoric acid. Chloride becomes hydrochloric acid. Bromide becomes hydrobromic acid, and iodide becomes hydroiodic acid. Now, what you're going to find is that if we have sulfate, whoops, Do you guys remember the little thing to remember the 8 ions and how they turn into acids? I ate something icky. So if I have sulfate, that becomes sulfuric acid. You notice, is there a hydro there? No, and that's because it's not an "ide" ion. It's an 8 ion. If you have an 8 ion, it's just I ate something icky. If you have an "ide" ion, fluoride, chloride, then it's hydroic, hydrochloric, hydrobromic, hydrosulfuric. And then you'll notice we also have an "us" over here. Anyone remember the little mnemonic device for "us" acids? My Sprite. Whoops. Is delicious. So if you have nitrite, when we make it into an acid, it becomes nitrous acid. So this is all about, this particular worksheet is just about recognizing. You'll notice that all of the acids either have H at the front, H at the front, H at the front, or what's the other thing they can have? Tell your partner, everybody tell your partner, acids either have H at the front or they have COOH at the end, organic acids. Excellent. All right, and these are just a whole bunch of example acids that you can look at from time to time if you're interested. Now we're going to go on to page 79. Now, if you are getting stuck on acids, you'll notice, what do we have here? We have a Tyler DeWitt video, okay? So feel free to watch those, and he's got some acid practice problems. Here we have our little summary. My ride has hydraulics. I ate something icky. My Sprite is delicious. All of our ide ions become hydroic acids. Hydroic, 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 hydroic. This is the last thing you need to learn, is that sulfur and phosphorus are a little bit weird. Normally, you would take a look at this and you would say, I have sulfide, and you might think I must have sulfic acid, or sorry, hydrosulfic acid. Hydrosulfic acid. However, that is incorrect. Sulfur and phosphorus each need an extra syllable. S and P need an extra syllable. So instead of hydrosulfic, it's going to be hydrosulfuric. acid. So you basically just write the word sulfur in the middle of the acid name, okay? If we have, and this would be H2S, if we had H3P, instead of hydrophosphic, it's not going to be just phosphic, it's going to be hydrophosphoric. Acid. So sulfur needs an phosphor needs an or. Sulfur needs an phosphor needs an or. And I'm just going to write phosphor rather than phosphorus. Sulfur needs an phosphor needs an or. So they need those extra syllables. Nobody else does. I'm not quite sure why they needed them for this one, but there we are. They're just little, and that happens whether you have sulfide, sulfite, or sulfate. Doesn't matter which one. So let's just take a real quick look at, do we have room on here to write something? I don't know. I'm going to write it over on the side. You can feel free. Is there a place? There's not really a very good place. Maybe down at the bottom here. H2S. H2SO4 and H2SO3. S2 minus is sulfide. SO4 2 minus is sulfate. And SO3 2 minus is sulfite. Do you think you could give those their acid names? Do you guys think you could name those three acids? Give it a try. So sulfide, we need to have the hydro and the ic. And because it's sulfur, sulfur needs the extra So instead of just sulfic, it's going to be hydrosulfuric acid. H2SO4, we have the 8 ion. And if I have an 8 ion, I just add ic to the end. So normally it would be sulfate would become sulfic, but I know that sulfur needs an so it's just sulfuric acid. My Sprite is delicious. So if I have sulfite, I'm going to have sulfur. Again, I need that extra little in there. Okay. And that sulfur, because it's an ite ion, the ending is us, acid. What do you guys think? Is it making some kind of sense? Yeah? Okay, good. Good, good, good. We are going to go now backwards. Okay, so I will let you practice these once we're done here. But we're going to go to 4.5c, which is writing the formulas of acids. And once again, there are some good little videos here. So if you're like thinking, Ms. Spence, your explanation was not good enough for me, there's some really nice explanations here. When you go to write the formula for an acid, it is like the formula. It's done like ionic compounds. How did you write formulas for ionic compounds? Like, let's say I gave you calcium hydroxide. How would you write the formula for that one? You would say I got Ca, and you would need to know its charge, it's 2+. And hydroxide, where would you look to find hydroxide? On your polyatomic ion sheet, so take a look. It is OH -1. So remember, there's two ways to write the formula. You can either write out more ions until you have the same overall positive charge and negative charge. Or if you prefer, you can crisscross. And then if you need to, you would simplify. So this would be Ca, and that's just a 1. And then OH2. I would like you guys to critique this formula that I have written. Tell your partner, what is wrong with what I have written for this formula? What's one thing that's wrong? No one. And I forgot the brackets. So yeah, you would have to have CaOH2. Now you could get that same result by having this one here because you have 1 Ca and 2 OHs. Okay? So same method when you're writing the formula of an acid. So let's say I gave you hydrophosphoric acid. So you'll notice we have a hydroic. What is the little sentence that helps us remember? My ride. has hydral X. So what kind of an ion are we looking for? We're looking for an ion that ends in ide. So this is going to be phos. And remember that phosphorus has that extra ore, so it's just going to be phosphide. What is the symbol for phosphide? No, it is not PO4. Where do you find most of your ide ions? Other than hydroxide and cyanide, these are mostly on the periodic table. Yes. So who is phosphide? P. What is the charge of P? It's in group 15. 3 minus. Now, in order to write our ionic compound, we had to balance the charges. We had a cation and an anion. Who is the cation in an acid? Who's the cation in an acid? Always. You don't know? What do all acids have in common? Hydrogen. So who's the cation? Hydrogen. So the cation in acids is always H plus. Okay? So you would just do this like you did an ionic compound. You would say, I have a total of 3 negative. That means I need to have 1, 2, 3 hydrogens to give me 3 positive. So that means I have H3P. If you prefer to crisscross, the 3 will come down here, so we have H3, and the 1 comes down here, but we don't want write the 1, so it's H3P. Okay. What if I gave you nitrous acid? What is the sentence that helps you remember? My Sprite is delicious. Okay, my Sprite is delicious. And so that means we have the nitrite ion. You can go look that up on your table of polyatomic ions. And it is NO2 minus. Who's going to be the cation that goes with it? If it's an acid, the cation is always H plus. So we're going to say, okay, H plus. Isn't that nice? I have the same positive as negative. I don't need to do anything. I just write HNO2. So your job today is to finish off any quizzes up to number 8 that you have not done and to start working on quizzes 9 and 10, okay? And if you're finished 9 and 10, you can take a look at hydrates. They're fairly easy to learn on your own, but if you get stuck, you can call me over and or bring your stuff up to me and ask me about it. And if you've done everything, I did run off the organic stuff today. So if you're interested in that, I do have it.
Oh, Miss Ben, did you mark the acid quiz from yesterday?
I think I did. Where did I put my bag full of stuff? All right. And Caleb. I think maybe you had that back already, but it was on the floor, so
Oh.
yeah. Pardon me?
There's no quiz.
There's no quiz 7A's left. Oh no. Okay, hang on.
Well, there is, it's just in the 7B section.
Oh. Then let's go put the 7A's into the 7B section. Or 7. Let's take a look. Okay. They're not looking bad. Yeah, I think they're good. Phosphorus trihydride said, yeah.
Oh, yeah.
Okay, I'll just mark this for you real quick. So guys, that's all it is. Y and then I've got oh no, that was quiz 6. Very nice.
Thank you.
Okay. Christy. Hiya.
Was the next, 12?
Yeah,
Oh, and like 13 or 14, is that like more quiz?
it's organic stuff. And I do have an answer key for that, but it was just being run off, so I'll go grab it later today, okay? And Marco, I actually have your quiz number 9 here. Lauren. Thank you. Wilfred.
Oh, no.
Rajan. Megan. Thank you.
You do 10 now?
You can do 10 now. Yes, absolutely. Yeah. Right. I figured. Seven. Hi.
I have a question.
Yes.
So for the somebody put
Hydro.
in front of it.
Yeah.
But why?
Because my ride has hydraulics. So if you have an "-ide" ion, use hydroic.
Okay.
Okay? Yes.
Good.
Did I do quiz 10? Oh. Because I think I can.
I don't
skip-
know.
Because I actually don't remember.
You can look through here.
Because that's my quiz 11.
Yes.
So I don't know if I did quiz
Well,
10.
you can look through there and see if you can see yours.
I did not.
Okay.
Oops, I skipped one.
Oops, that's okay. You can always go back. Adam. Sky. Thank you. You are welcome. Steffi. Oh, wrong one, sorry. Matthew. So anytime you have an 8 ending what's on your polyatomic ion table, the single elements will all be "-ide". Yes. Okay, and we would look for hydrogen sulfate. Yeah. Hello.
Number 7.
Uh-huh.
I don't understand why. Like what's saying.
Okay. Basically, you just need to make the charges equal each other.
Okay.
So what you would do is you would say, I have copper 2+ and I have CH3COO-.
Mhm.
So how many CH3COO- do I need to make it equal to the 2+? I need
Oh,
2 of them,
One.
right? Because I've got a 2+ here and I've only got a 1- here. I need to add. So because I had to write them all separately, I need 2 of those to equal that one charge there.
And then you put the 2.
That's right,
I don't see
exactly.
the numbers because then I was like, how did you get this and this to equal that? But I don't
Right?
see the
Yeah,
lines.
so maybe I should put lines in between them or something. That might make it better, but is it making more sense now?
Yeah, because this
Yeah.
would be like 1 and 1. And then you have to have those
3,
that one.
yes, exactly. Or you can do
Okay.
the crisscross, either way.
And it's just
Okay?
the lines
Yeah,
to
yeah.
see that.
Yeah, no, that makes sense.
All this fast, can I use the washroom?
Yes. Matthew. Thank you. Yeah? Okay. Thank you. Oh, your quiz is here, Steffi. Ari. So this was all good, just this one you gave me the total charge rather than charge on a single ion.
Oh.
Yeah?
yes.
Yeah.
I'm just gonna wait here. 'cause
Yeah,
that's my other
And I was
sheet.
gonna say, you've got this one also, so,
Yeah,
this one, which do you need two of to make the charges equal? You have 4 plus and a 2
oh.
minus. So you did that
yeah.
backwards, yeah.
And then that one is. Yeah, I
Hydroxide,
realized when
yeah.
Matthew brought this back.
Okay, and then this one, I haven't marked yet, but it'll just take me a second. Phosphide. Yay!
Thanks.
Marco. No Roman numerals in the formula.
after this one,
Mm-hmm.
because it has the Roman numeral, what would I
Mhm.
do with that after I?
So you would say 3 plus 3. Oh, actually, yeah, the 3 doesn't mean there's 3 of them. That means it's a 3 plus charge. Yes.
So then I have to make that equal to,
Yes.
how would I do that?
Well, if you have a 3 and a 2, the lowest common multiple is 6.
Mhm.
Yes. So how many of those do you need to get 6?
Mm,
You need one more, right?
mhm.
And then this one, how many do you need to get 6? 2 more. So you would have 2 of these and then 3 of those.
Okay.
Yeah. Steffi. There you go. Sky. Yay.
Thank
And
you.
Could you take that to Rajan, please?
Alright.
Yeah.
Sitting.
Oh, did he leave? Oh, no, he's in the back corner, very, very far back. He's not actually there right this moment. Thank you so much.